The topic of this video is really walking through how you can prove what type of triangle you have created here with the coordinates. And so please, if you're not sure how to prove these things, go back and watch the how do I prove triangles video that I've posted. But the first thing you want to do is go ahead and plot your points, and you really want to make sure if you plot something that looks a little funny, please double check your coordinates before you begin so that you do not plot something that's not correct, because the entire thing is a domino effect. 1, 2, 3, 4, 5. Okay, so here is my triangle that I'm dealing with. And once I connect it, I can kind of move through. So if you remember from class or from the previous video, there are two things that I need to calculate, right? I need to calculate the distance and the slope of this triangle. So I'm going to start with the distances first, okay? So I'm going to look at making these triangles all the way around, these smaller triangles all the way around this larger pink triangle, right? So there are my smaller triangles. I'm going to color this in so I can remember this is the one I'm dealing with. Okay, so I want to find the slope and the distance of each of these side lengths. So I'm going to start with the green, and remember I move left to right. So this is already a negative slope. I can see that. I move down 1, 2 and over 1, 2, 3. Okay, so oops, I said I was going to find distance and I just did slope instead. So for that section, I have a negative 2/3 slope. And then I can actually use that for distance as well. Remember not to use negatives when we're doing distance because that doesn't apply, but I'm going to do 2 squared plus 3 squared, which gives me, let's see here, that's 4 and 9, that's 13. So the square root of 13, which is 3.6. Okay, so that's that side length. And then I'm going to go to the gold, and I've got a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6 and 4. So let's see here. This is an up slope. I can see that line is moving up. So this is an up 6 over 4, which is 3 over 2 when you reduce that. Okay, so please don't forget to reduce. And then when I do Pythagorean theorem for this, I've got 6 squared plus 4 squared, which is 36 and 16, right? Which is 252. So the square root of 52, which is 7.2. All right, we got one left. That's the purple. So 1, 2, 3, 4, 5, 6, 7, 8, and 1. So, and this is definitely from left to right. This is moving up. Even though that looks deceiving, it's definitely moving up. So this is an 8 over 1 slope. And then I've got 8 squared plus 1 squared, which is square root of 65, which is 8.1. All right, so the first thing I can see is that there are no lengths that are the same. All of those lengths are different. The second thing that I can see is that I've got perpendicular lines right here. I've got the exact same number, and one's positive and one's negative. So because there are no equal sides, I'm going scalene. And because I have perpendicular lines, I'm going right. And then I'll just go ahead and say that it's also a triangle. So that's kind of the process that you want to kind of go through. I want to be very clear. I would have never seen that these were perpendicular lines had I not reduced my slope fraction. So please make sure when you're doing these that you reduce or check for reducing every single time. And that's kind of how you'll proceed, right? So if you, if we were to do one more here, if we were to check this one down here, and I apologize for the old version of this form. So if I were to plot these points, I've got 0, 0, 3, 7, and 7, 1, 2, 3. I've got this right here, right? So if I connect my points, okay, so again, let's make our triangles on the outside. This has a 3 by 1, 2, 3, 4, 5, 6, 7. That's a 3 by 7. This triangle is 1, 2, 3, 4 by 1, 2, 3, 4. And this triangle down here is a 3 by 7. So right off the bat, I can definitely see some distances working out for me, right? So I've got a 7 squared plus a 3 squared, which 49 and 9 is 58. So the square root of 58 is 7.6. And I'm going to have, so that's, let's say this one right here. I'm going to have that exact same thing for here, right? 7 squared plus 3 squared, which is the square root of 58, which is 7.6. So right there, I know I've got 2 equal sides, okay? The last one, just for funsies, that would have been the square root of 32, which is 5.7. When I go to find the slopes, because what if they're opposite reciprocals, right? So left to right, so this is the farthest left, moving right, that's a positive slope. So I've got a slope of 7 over 3 on that one. And but for this one, for this line right here, again, if I move left to right, that's that way, that's a 3 over 7. So while they are while they're reciprocals, they are not opposite. And because of that, there are no perpendicular lines, right? And the last one had a negative slope of 4 over 4, which is -1. So no perpendicular lines at all. So this is just, so there's nothing to say about a right triangle based on this. The only thing I can say is that there is an isosceles triangle here, and that would be it. So hopefully you've recognized how important distance and slope are to this success. If you have any questions or that was too fast, or you need any kind of like little things taken care of, please don't hesitate to ask.